Section 1.10 is the last section of Chapter 1, and it's all about density. And so we're going to do some comparisons because density is actually kind of important, and it can tell you a lot, even with biological functions. For instance, if somebody's dehydrated, they're going to have a higher density of bodily fluids than someone who is not. So there's some connection there with medical as well. So if we just do some simple comparisons to just begin with, for instance, we have the cork that's floating on the very, very top. It's the least dense, and it's floating because it's the least dense. This always surprises people. Ice is actually less dense than water. They would think that it would be the same because it's the same compound, but it's not. Water actually expands when it freezes, giving it a lower volume, or a greater volume, which means that the top number is going to get smaller. Which makes sense if you think about it now, because ice floats. Because of the fact that it's less dense, that's why it's floating. And then we have lead at the very bottom, because it's the most dense. The actual equation for density is mass over volume. It compares the mass to its volume. That's the whole point of it. Now, these are the units that they gave us, but keep in mind that those units don't necessarily have to be grams per centimeters cubed or grams per milliliter. It could be pounds per square inch. It could be, and that's actually pressure, pounds per cubic inch. It could be kilograms per liter. It could be all kinds of different units, as long as it's a mass over a volume. Here are just some common examples. We already looked at cork, and you notice that if you're next to a lake or a river, wood floats because it's above 1, which is the density of water. If you ever combine water with oil, you'll notice the oil floats to the top because of the fact that it's less dense. If you are swimming in a swimming pool and you see somebody has lost their jewelry, it sinks to the bottom because it's more dense than water. So let's just jump right in and do some examples. What is the density in grams per centimeter cubed? Notice that they tell you what the unit is because it could be several different units. At 50.0 grams of osmium and 2.22 centimeters cubed. So density is equal to mass over volume. So we're looking for density. The mass they gave us is 50.0 over 2.22 centimeters cubed. So it would be 50 divided by 2.22, which comes out to be 22.5. 3 significant figures here, 3 significant figures here. Therefore, we want 3 here. That gives us to 2. Now, something to make note of. They didn't tell you it was the mass of 50 grams. You have to know that grams means mass. They said volume of whatever centimeter cubed. They didn't have to say volume. You should know that centimeter cubed automatically means volume and grams automatically means mass. That's something that you're going to have to practice and memorize. Let's try another one. We have 40, okay, what is the density? So we're looking for density is equal to mass over volume of 48.0 grams. You see grams, that means that's our mass. Sample of a metal. If the level of the water in a graduated cylinder rises from 25.0 milliliters to 33.0 milliliters after the metal is added. We have 2 different things of milliliters here. We had to figure out what to do. So essentially what they have is, here's a graduated cylinder. They have 25 milliliters of water in it. They've put it in here, and the water went up. So they want to know what this actually is on its own. It's kind of like if you filled up your bathtub and then got in it, the water rises. It's called displacement. What you actually end up having to do is subtract. And that comes out to be 8.0. I keep that 0.0 there because that's where the significant figures in. When we're adding and subtracting, that's what we do. We line up the significant figures. So now we can plug this into our equation. So density is equal to 48.0 grams over 8.0 milliliters. And that comes out to be 6. But we have 3 significant figures here, and we have 2 significant figures here. That means we want to have 2 in our answer. So instead of saying 6, we want to say 6.0 grams per milliliter. Now, it asked for centimeters cubed, and they gave us our volume in milliliters. That doesn't matter. Remember, grams and milliliters and centimeters cubed are the same thing. So you don't have to worry about that. And our answer would be 2. Now, this is starting to compare densities, which is something we did at the very, very beginning, where we start looking at, okay, so a cork will float because it's has a really low density. Ice floats because it has a low density. If you ever look in an ice bucket at a party and you're looking to grab a soda, you'll notice that all the diet ones are floating and all the regular ones have sunk to the bottom. That's because of the sugar inside of the regular ones. That means that the sugary pops actually have a far higher density than a diet pop because of the difference in the sweeteners. So let's take a look at this one. So let's take a look. We have syrup, which is 1.4 grams per milliliter, vegetable oil, which is 0.91, and water, which is 1.0. At the bottom is going to be the one with the highest density. So that means that this syrup is going to be on the bottom. Long and behold, this is the only one with it at the bottom. Then the next one will be the next highest, and the lightest will be the one on the top. There's the B, because it's the top is the lightest, the lowest density. Water is 1.0, it's the middle one. If you choose, you do not have to do it this way, but if you choose, you can decide to use 3.8 grams per milliliter as a conversion factor. Remember, per means one of whatever the unit that is, like miles per hour or meters per minute, like we've done in previous problems. That just means over 1 minute, over 1 hour, over 1 milliliter. If you want to use that as a conversion factor, like this, please feel free. It's totally up to you. Alright, so the density of octane, a component in gasoline, is 0.702 grams per milliliter. What is the mass in kilograms? Notice it's in kilograms and they're asking for grams. Or they give it to you in grams. That means we need a conversion factor there. Of 875 milliliters of octane. Okay, they didn't say it's the volume, but I know because it says milliliters, that's going to be my volume. And we're looking for mass. So D is equal to M over V, which means 0.702 grams per milliliter is equal to M over 875 milliliters. To get M by itself, we need to cross multiply. So M is equal to 614.25. 3 significant figures, 3 significant figures. That means I want 3 here. So we have 614 grams. Although it asked for kilograms. So that means we need to use the conversion factor on the top. So 614 grams over 1,000 grams, 1 kilogram. 0.614 kilograms. That would be A. That is the end of chapter 1. Make sure to do the end of chapter practice problems for your own good. They will not be collected, however, they will be very helpful for you.